All right, just a review. We talked about this before. All right. So the relative rate of alkyl halide for an SN1 and SN2 are reversed. For an SN2 reaction, the smaller the better, right? Because the high sterically hindered alkyl halides slow down the rate. Okay, high steric effect. So for the rate of an SN2 reaction, we prefer small alkyl halides of methyl primary or secondary. Tertiary blocks backside attack. For an SN1 reaction, reverse, because the bigger, the more sterically hindered, the higher degree of hyperconjugation. All right, like tertiary. 3-methyl group helps stabilize the carbocation in the middle, right? And the relative rate will go tertiary, followed by secondary, primary, and methyl. Never do an SN1 reaction. All right. Basically, if you look at the structure of an alkyl halide, you should be able to predict if it go in SN1 or SN2, unless if you start with a secondary. Secondary can go both ways. Okay. All right. Now, can this guy go SN2 if you remember? Well, and I'll start with the allyl halide. This is not vinyl. This halide is not on a vinyl position or on a double bond. It's not vinyl. Okay. Start with an allyl halide. Can this guy go SN2? And allyl halide, yes. Benzyl also yes, because this position right here is relatively unhindered. All right. This just look like a primary alkyl halide. See that? So you can do an SN2 with this guy. All right, so we have an allyl and benzyl halides. You don't have to memorize the name. You just look at the structure. This is primary carbon. This is primary carbon. You can do an SN2 reaction. One of the best substrate for an SN2 reaction. All right. So yes, for SN2. Can it go SN1? What happened to it when this guy go SN1? Well, look at the carbocation, right? So you should ask yourself that, is this carbocation stable enough to do an SN1 reaction? Well, I'm going to say yes, because it got stabilization. This is allyl carbocation, right? Benzyl is even better. Take a look. You can draw a resonance form right there. There are 4 resonance forms. Stabilize that carbocation. So allyl halides and benzyl halides can do both SN1 and SN2. Okay. Now, vinyl. This is vinyl. This is halides on a double bonded carbon. First off, can it go SN2? Backside attack? If you remember, no, because too high electron density, right? If hydroxide want to attack, have to attack from that position or have to get inside the ring and attack that position. High electron density, very highly electron density, not going to happen. Can't get into that backside attack position. So no SN2. Okay. Can it do an SN1 reaction? All right. So if this were to go an SN1 reaction, so you should see a stable carbocation, right? Let's see if the carbocation is stable enough. What do you think? Oh, nothing stabilizes carbocation. No, that's even worse, right? Nothing stabilizes it. So nope, can't do SN1 either. So vinyl halide and aryl halide never do substitution reaction, never, right? It will actually go a different type of reaction. You will learn it later. This guy will learn it in next class, organic chemistry too. If you don't take it, don't worry about it, right? Vinyl halide do something else, but we'll learn it later in the next chapter. Okay. All right. Now, if you want to do a substitution reaction with this, which one will go better? SN1 or SN2? Look at A right here. So totally that start with an SN2. Can it go SN2 though? Tertiary alkyl halide. No, this is the worst substrate for SN2 reaction. Or tertiary block backside attacks. Too high sterically hindered. All right. SN1, yes, good substrate for an SN1. When bromine leaves, it will leave tertiary carbocation, which is good for SN1. Good. All right, that's an A. Now go to B. Start with an SN2. What type of alkyl halide is this? This is primary alkyl halide, so good for an SN2. Love for an SN2. What about SN1? If chlorine leaves, what type of carbocation do you get? Let's get kind of blank. Primary carbocation, which is one of the worst carbocation. So nope. C, an SN2 reaction. This is vinylic position. Halides on a double bond, not block backside attack entirely, like too high electron density. the nucleophile cannot get in between inside the ring and attack from that position. So no SN2. What about SN1? Can you form carbocation here? Well, you can, but nothing stabilizes it, right? The carbocation is not going to be stable. So nope, not either. All right. Okay. Let me check real quick. So get. All right. Let's take a look at the next video. We go to nucleophile.